Hey there, hope you're having a wonderful day. In this video, we're going to create platforms for our game and detect collisions with the platforms. So just to show you what we have so far, if I save and run the program, you can see we have all the jumping mechanics and we have this invisible floor over here, which we will remove in this video and replace with platforms. So if you go to the GitHub repository, link is in the video description below, you'll find all of these images available. And for our platform, we are just going to use this floor tile. Now, there are other tiles, such as these rock tiles, and we have a wall tile. For this tutorial, I'm just going to use floor tile. And in the later tutorials, we'll create a map for the game and use these other tiles. Alright, so each tile is going to be 32 pixels by 32 pixels, so each tile is a square, so we don't have to create a separate variable to distinguish the width and height like we did over here. So I'm just going to do tile size and set it to 32. Next, we need to load the tile image, so down here, I'm just going to use this load image function. So floor tile image load image, and the image name is just floor-tile.png, and the width and height is just going to be tile size. Alright, so we load the image. Now let's create some tiles, and we're going to have multiple tiles, so instead of creating a single variable to reference the tile like we did with the player, we're going to create a list that will store all the tiles. So let's scroll down, and over here I'm just going to move this piece of code and place it over here right before our game loop. So this is going to be where we start the game, so I'm going to place all our game variables here. And as I mentioned before, we need a list to store all the tiles, so I'll create a variable tiles and set it to an empty list, and I'm going to create a function called create map. So I'm going to call that function over here, but we need to define this function. So let's scroll all the way up, and I'm going to place this function over here. So create map. And for this function, I'm going to create a bunch of tiles, and I want to create a class to represent the tile because we want to save the image information since we can have multiple tiles of different images. So here I'll do class tile. And this is going to inherit from pygame.rect. So it's similar to what we did with the player class. We just take on the properties of rectangle and add more to it. So I'm going to create a constructor. And unlike with the player class, the tiles can appear in different parts of our map. So I'm going to have the user specify the X and Y positions. And we don't really need to specify the width and height because we know that the width and height is going to be tile size. So we're just going to specify the X and Y positions, and we're going to specify the image. So let's call the rectangle constructor. So pygame.rect._init. And we're going to pass in self, X, Y, and the width is going to be tile size. And the height is also going to be tile size. And then we're going to do self.image is equal to image. So we're just going to pass in an X and Y coordinate and the image, and we create a rectangle here and we save the image. Okay, so let's create our map. Now I'm going to create 3 sections of platforms. So the first is going to be for I in range for tile is equal to tile. So the X position is going to be player.x. So it's going to be in the same X position as the player, except we shift it based on which tile we're creating in the row. So this is the starting position, which is the same X position as the player. And I'll do player.x plus I times tile size. So the first tile is going to be where I is 0, so it's just going to be the same as player X. And then the next tile is going to be for when I is 1, so we shift the X position over by 1 entire tile size, which is 32 pixels. And then in the next for loop, we're going to shift it by 2 times tile size, so 64 pixels, and so on. And for the height, I'm going to make it player.y, So it's going to be starting from the same height as the player, except we're going to push it down. So I'll do plus, and here, let's make it 2 tile sizes down. So 2 times tile size. Or maybe we should write it the other way around. So I'm going to do tile size times 2. And then we need to pass in an image for the third parameter. And this is going to be floor tile image. And then after that, we need to add this tile to the list. So tiles.append tile. So once we create these 4 tiles, we need to draw them. So over here in our draw function, I'm going to do for tile in tiles window.blit tile.image and tile. Alright, now before I save and run the program, I want you to think about where we are placing these 4 tiles. So I definitely recommend you get a sheet of paper and try to draw it out yourself and try to figure out the math. This will definitely help you with your programming skills if you can have a vague picture of where things are going to be placed on the interface. So yeah, just take a piece of paper, draw a rectangle to represent the screen, and the top left corner is 0, 0. So see where these 4 tiles are going to be drawn. Alright, let's save and run the program. And you can see the 4 tiles are drawn over here. Okay? Alright, so hopefully you tried to figure this calculation out yourself, and if you did not do so, I'll just quickly show you. So actually in my screenshot, I have Mega Man over here, but if you remember in our previous videos, we made Mega Man start at the middle of our screen, so somewhere around here. So this box will be Mega Man, okay? And this is the X coordinate, and this over here is the Y coordinate. So for the Y, we're looking at the top of the box, and for the X, we're looking at the left side. So we're iterating from 0 to 4, and this does not include 4, so it's 0, 1, 2, and 3, and we have the X position, which is player.x plus I times tile size, and the Y position is player.y plus tile size times 2. So this is where Mega Man starts, this pink box. So the Y position stays the same regardless of which tile we're looking at, and that is because it does not depend on I. So it is player.y, which starts over here, and we add tile size times 2, which is 64 pixels. So we're basically pushing it down. So this is where the Y position is for all of our tiles. Now what about the X position? Well, the first tile is going to have the same X position as player.x because I is 0. So if I is 0, this gets canceled out. So same X position would be over here. Okay, and then the next iteration, we have I is 1. So X is going to be player.x plus tile size. So player.x is over here, we add tile size, and we get over here, okay? And then we add 2 times tile size for the next one, which will be over here, and then 3 times tile size. So it's going to be starting here, okay? So that's how you can calculate the X and Y positions of the tiles and create them consecutively so that they're right next to each other. All you have to do is shift them by I times tile size. And if I want to create a vertical one, like so, then the X position stays the same. So you can see the X position stays the same for all these 3 tiles. It's just that the Y position is now shifting by tile size times I. So it's going to shift down like so, okay? So let's create these other 2 sections. So this vertical section and this long horizontal section. So for this long horizontal section, it's going to be similar to this one over here in that Y is going to be the same. So it's going to be up to over here, which is Y, and the X position is going to change. So it'll be, instead of player.x, it would just basically be 0. So it's going to start at x equals 0, and then we shift everything by I times tile size. So first iteration, I is 0, so we have x0. Then we shift it over by tile size, then 2 times tile size, 3 times tile size, 4, and so on. Okay? Alright, so let's create the other 2 sections. So here I'm going to create the long one at the bottom, and this is going to be horizontal. So I'll do for I in range 16 tile, and the X position is just going to be I times tile size. So if I is 0, that means the first tile is going to start at x equals 0. And the Y position, so how far down we want to place these tiles, is going to be player.y plus tile size times 5. And then the image is floor tile image. And you can see for the Y positioning, there's going to be a difference of 3 tiles between these two platforms. And then let's add the tile. So tiles.append tile. And let's create one more section. So this is going to be vertically. So for I in range 3, tile is tile. And in this case, the X position stays the same. So I'm going to do tile size times 3. So it's 3 tiles from the left. And what about the Y position? Well, they're stacking on top of each other. So this is going to be changing. So I'm going to start at 10 tiles down. So it's going to be I plus 10 times tile size. And then the image is floor tile image. So this is going to be 10 times tile size. So 10 times 32 is 320 pixels from the top. So this is going to be for the first one. And then the second one will be 11 times tile size. And then the next one will be 12 times tile size. So we're offsetting it by 10. So it's not starting from 0, 1, 2. It's going to be 10, 11, 12. Okay? And then let's add the tile. So tiles.append tile. All right, now let's save and run the program. Okay. So you can see we have our vertical tiles over here. So as I mentioned before, this is starting at 10 tiles down, and then 11 tiles, and then 12, okay? And over here, X is starting at 0, so we just create a long platform of 16 tiles. So now we have our tiles, and therefore we don't need this invisible floor anymore. So I'm going to get rid of it. So I'm going to get rid of floor Y, and then let's scroll down. And we're going to get rid of this piece of code as well. Okay, now let's save and run the program and see what happens. Oh, you can see Mega Man fell. And that is because we do not detect any collisions between Mega Man and the platforms. So from our eyes, we see that the platforms exist, but the code does not see them as platforms. Instead, they're just a visual decoration. So we need to add some collision detection. And collision detection is actually detection between two rectangles. So we're detecting a collision between two rectangles. This basically means an intersection between two rectangles. So we can have the player over here, and we can have a tile over here. And this doesn't look like a rectangle, but Mega Man over here is actually a rectangle. And that is because we have a width and height, so it's a transparent image, but the image is still a rectangle. So to detect the intersection between two rectangles, there's actually a specific formula, but luckily for us, in Pygame, we don't have to write the formula out ourselves. The formula is actually very simple, but we actually have a function that does the calculation for us. If you want to know what the formula is, maybe I'll leave it in the video description. So over here, right below the create map function and above this move function, I'm going to create another function, and I'm going to call it check tile collision. And this is going to iterate through all the tiles. So for tile in tiles, if player.collideRect tile, we're going to return tile. Else, I'm going to return none. So this function is just going to give us the tile that we collide with. Now we need to decide what to do after we collide with a tile. So let's say we have a tile over here, and I'm going to have Mega Man collide. So here we're returning this tile if we collide. Now if I collide from the right side, what should we do? Well, we should stop Mega Man from moving forward and place Mega Man right here next to this tile. And if Mega Man is falling down and we have a collision like so, then we want Mega Man to stay on top of this tile. So how do we determine where the collision is coming from? Well, we can just use the velocity. So if I'm colliding from the left side, that means Mega Man must have been going to the right side. So in this case, we have a positive x velocity. And if I'm falling down, we have a positive y velocity. So when we detect a collision, we're going to check the velocity x and velocity y. So if Mega Man is falling down, we're going to place Mega Man on top of the tile. If Mega Man is jumping and we bump into the bottom of the tile, we're going to stop Mega Man over here. And if we are going to the right, we're going to place Mega Man to the left of the tile. And if we're going to the left, we're going to place Mega Man to the right of the tile. So we're going to break this down into two directions. we're going to check the X direction first and then the Y direction. And the reason is, what if Mega Man is jumping and we have a collision like this? Can you tell me if this is a horizontal or vertical collision? It's hard to tell, right? Because Mega Man could have been falling down or going to the right. So what we're going to do is check for the X position first. And if we're going to the right, we're just simply going to push Mega Man back like so. So Mega Man will be over here instead, and then we can let Mega Man fall down. All right, so we're going to check collision in the X direction first, and then the Y direction. All right, so we have the tile that we collide with. Now I'm going to check tile collision X, and we're going to do tile, check tile collision. If tile is not none, that means we collide it with a tile. I'm going to make a check if player.velocity x is less than 0. So this is going to the left. We're going to place Mega Man to the right side of the tile. So player.x is equal to tile.x. So this is the left side of the tile. To get to the right side, we add tile.width. Elif player.velocity x is greater than 0. So we are heading to the right side. I'm going to set player.x equal to the left side of the tile. So tile.x is the left side of the tile, but we want the player to be to the left of the tile. So this means that the right side of player.x should be touching the left side of the tile. So to get the right side, we would actually have to add player.width over here. And we want to modify the x position, which always starts from the left side. So what we can do is subtract player.width from both sides. So here I'll just do tile.x minus player.width. Once we've moved the player to the left or right side of the tile, we want to stop the player from moving. So player.velocity x, we'll set this to 0. Okay, so that's collision detection for the x direction. Now let's do the same for the y direction. So same thing, we're going to check for the tile. If tile is not none, so we're going to check if we're going up or down. If we're going up, that is in the negative y direction. So if player.velocity y is less than 0, if this is the case, this means Mega Man jumped up and bumped its head against the bottom part of the tile. So at that point, we want to stop Mega Man from jumping any further. So we're going to place player.y equal to tile.y plus tile.height. So this is going to be the bottom part of the tile. Elif player.velocity y is greater than 0. So this is in the positive y direction. That means Mega Man is falling. If that is the case, I'm going to do player.y and set it equal to tile.y. And just like with over here, we want the bottom of the player to touch the top of the tile. So to get the bottom of player, we need to do player.y plus player.height. And since we can only control the top side, we're going to subtract player.height from both sides. Okay. And one more important thing, if the player lands on the tile, then I'm going to do player.jumping and set it to false. So basically, the player is now on the ground, and I'll do player.velocity y and set it to 0. All right, so now we have the functions for detecting collision in the x direction and the y direction. Now we need to call these functions. All right, so over here, I'm going to split the code into two. So we have the x movement and the y movement. So when we move player.x, we want to make the check after we move the player. So here I'll do check tile collision x. And then over here, for the y movement, I'll do check tile collision y. So the idea is we move the x position first, check to see if there are any collisions with the tiles, and then we move the y position and check to see if we have any collisions with the tiles. So let's save and run the program. All right, I fall down. You can see we land on this platform. And you can see we actually have some weird behavior going on. Can you guess why? So the reason is actually due to the width and height of the player changing. So if you look at our tile collision functions, we are calling collide rect, which detects the intersection between two rectangles. The problem is, over here, we are constantly changing our width and height depending on whether Mega Man is jumping or not. So let's say we have Mega Man over here. If we jump, we're going to make the width and height bigger. So we get something like this. And as soon as we jump, we change the width and height, and you can see we now have a collision. So how do we resolve this issue? So originally I was going to do some adjustments where if we jump, we're going to shift the X and Y position upwards a bit so that Mega Man's feet would not automatically be touching the ground. And the same over here, if we jump over here, then the width and height is going to expand like so, and we're going to collide with this vertical platform. So the idea was I was going to just push the X and Y position upwards. So I did do a lot of calculations and it turns out to be very complicated. There's a lot of edge cases. For example, if I'm jumping and I'm stepping backwards, what if I run into a wall or another tile? So let's say I was over here and I jump and I move backwards. Well, now I'm going to run into this tile while trying to dodge this tile over here. So there's just too many edge cases. So what I decided to do is actually play the game that this tutorial is based on, and you'll find something very interesting I actually didn't notice. And this is actually the game that we're going to be building. And you can see if I jump, Mega Man's arm and leg is pretty much intersecting with the tiles. And if I shoot, you can see Mega Man's arm gun is sticking through the wall. So essentially, Mega Man's rectangle actually never changes. So it remains the same as the original standing position. So if we jump, you can see the image gets bigger, but the rectangle stays the same. So we're just going to go with the same solution that the developers went with, and basically we are not going to change the width and height accordingly to the image. So if the image is bigger than the standing image, then we're not going to take that into account. So I'm going to get rid of this and this. So let's say we run the program. All right, so we have Mega Man, and if I jump, you can see Mega Man's leg when jumping actually intersects with the top part of the tile. And over here, well, you can see Mega Man cannot jump high enough, so let's adjust the velocity Y. So over here, instead of -10, we're going to make Mega Man a little bit stronger. So when jumping, it'll be -11. All right, let's save and run the program. Okay, so here you can see Mega Man intersects with the top of the tile. And over here, when we jump, Mega Man's arm and leg intersects with the wall over here. So we're just going to use the same solution that the original developers went with and proceed like so. That way, we don't need to do any complicated math. And ideally, when you're developing a game, you want the width and height to usually be the same regardless of the state of the character. So that's pretty much how Super Mario Bros. Work. The width and height does not change as drastically as Mega Man. Alright, so we have platforms and collision detection. And in the next video, we're going to start creating enemies and detect collisions with the enemies. So that's it for this video. If you found this video helpful, make sure you give this video a like. If you have any questions, let me know down below in the comments. And if you want to stay up to date for more Python game programming tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.